Section 10.4, empirical and molecular formulas. For this section, you are going to really have to make sure you've got your calculators and your fingers and your everything ready to go.
Your periodic table?
Yeah, your brain's on. Ready? All right, first thing's actually easy. Percent composition. Well, we think it's easy.
Well, yeah.
And
you can do a percent. Come on.
all right, let's hope so. The percent by mass of one element in comparison to the whole compound. So what you're going to have is you're going to have percent of composition of A is equal to the mass of A divided by the total mass of the compound. So we're going to give you a practice problem.
Okay.
You ready?
Yep.
Okay. Determine the percent composition of calcium chloride. In this question, they didn't actually say calcium or chlorine, so they're going to want you to find both. So what we have to do is, number one, add up the molar mass of calcium chloride.
Okay. Well, let's figure out what the formula is of calcium chloride. Ca has a 2 plus and Cl has a negative 2. So, chlorine has a negative 1.
Yeah.
I think whatever.
Yeah. Calcium is a 2
Crisscross
plus.
it. CaCl2.
Okay.
I think I messed up my numbers.
There you go.
Maybe not. Okay.
2 plus minus 1. Crissity cross. All right. If you add up 1 calcium and 2 chlorines, you're going to have a total mass of 110 gram per mole.
All right.
Because I'm adding those off of the periodic table.
Got it.
So what we're going to do now is we're going to see how much calcium is in that 110 and how much chlorine is in that 110.
Okay.
So calcium, since there's only one of them, we're going to go off our periodic table and we're going to find the calcium's molar mass is 40. And we're going to divide that by the total, so that's our piece divided by the total. 40 divided by 110
There you go.
equals 0.3636. Now, if it's percentage, we have to then multiply by 100, or in your head, you can move your decimal 2 spaces to the right.
Okay.
I need some sleep.
We have 36.36.
All right, chlorine, there's 2 of them, so you have to double the molar mass of the chlorine. So instead of just the normal 35, you're actually going to have then a total of 70.
Okay. Get 70 divided by 110.
70 divided by the total, so that's the piece over the whole, and you get 0.6364 times 100 gives you 63.64. Your double check now to make sure that you've done it correctly is your percentages. Each piece should add up to 100 or extremely close to 100. You might get like 99.9.
Right.
Which means you still did the math right.
The other thing that you could do is, you know that you have 36.36% of calcium, so to find your chlorine, if you knew that that calculation was correct, 36.36, you could say 100 minus 36.36, you have this amount of chlorine.
Yeah, subtraction.
Okay,
Ready?
you can do it.
Yes, you can. Now, why we had to do percent composition is because we have to use percentages when we do empirical formulas. So here's your empirical formula. Is the simplest whole number ratio of an atom in a compound. You're basically figuring out what the subscripts are if all they give you are just the element names: carbon, hydrogen, oxygen. How many carbons are you needing? How many hydrogens? How many oxygens? So we have to do some math to figure out what the subscripts are. And you've got some rules here. The first thing you need to do is convert percentage or gram into mole. So you're going to use your cheat sheet, use the triangle, convert gram into mole. Once you have all the things into moles, you're going to divide all the moles by the lowest mole, round to the nearest whole number, and then place the mole ratio as a subscript. However, if you get a number that is there's not normal rounding rules. If you get a number that's 0.9 or 0.1, you can either round it up or down. So 0.9 can go up, 0.1 can go down. But if you have a 0.2 to a 0.8, you have to multiply all the mole ratios until you get them to a whole number or a 0.9 or 0.1 that you're allowed to round.
Most of the time it's going to be like a 0.3,
Yeah.
so you multiply by 3, or 0.5 multiply by 2.
Yes.
We won't give you something that's like a 0.7.
That would
so
be
to multiply it all these times. No.
Yeah, that'd be really mean. We're not quite that mean. All right.
Just a little.
Yeah. All right, so let's do an example. Determine the empirical formula for the compound that contains 35.98% aluminum and 64.02% sulfur.
Okay.
So first thing I would do is take the percentage, and what we can do is, assuming that this is 100%,
Right.
then we know that each of these is worth that many grams.
Yep.
So we can take and write down the number of the aluminum as 35.98, but instead of percent, we can drop it and make it into a gram. And that's AL. And we need to convert that aluminum into moles.
Mhm.
So we would divide that by the molar mass of aluminum. So if we look on the periodic table, we're going to get it as 27. So 27 gram per mole. And the answer of how many moles is 1.33. And then we have to stop here and move to the sulfur one and get that to moles before we can go to our next step.
Okay.
So we're going to take our 64.02,
Mhm.
drop percentage, make that a gram, divide by the molar mass, which is 32 gram per mole.
That's an M.
We get 2.0 moles of sulfur. The next step on your rules, which all of these rules are on your cheat sheet, the back side in the upper corner,
Mhm.
so you can just follow along with that one instead of flipping through in your notes. We have to divide by the smallest mole. So the 1.33 is our smallest mole, so we're going to divide by that. And out of one of them, you're always going to get a 1. So the very first one, 1.33 divided
If
by
you
1.33
don't
is a 1.
Look again.
And then this one, the sulfur comes out to 1.5.
Okay.
This is where we have to pay attention to our rounding rules.
Yes.
The 1.5, we are not allowed to round up or down. We have to multiply. And when you multiply one of them, you have to multiply both of them. So if we multiply by 2, we're going to get it to a whole number of 3. Then we have to multiply the aluminum by 2, and we get a 2. This is your final number, and it will be your subscripts.
So basically what we're saying is you have 2 aluminum to 3 sulfurs. So now you got to write it not as a proportion, but as a formula.
Okay, so we're going to have Al subscript 2 and sulfur subscript 3.
So that would be your answer.
There you go. It's
Okay.
not that bad.
Not
So grams divided by the molar mass to get you into moles. Get the smallest mole, divide it by everybody there. Make sure that you've got your rounding rules. There's whole numbers. If it's not, you've got to multiply to make sure that it is a whole number or a 0.1 or a 0.9 so you can round.
Yes.
All right, that's empirical. Now what we're going to do is we're going to take empirical and go to molecular.
Yes.
So you have to first solve the empirical. Then the next thing you're going to do is add up the molar mass of the empirical formula. So it's just one more added portion to the problem. You're going to divide then the molar mass of the molecule given to you in the problem. So if you see a gram per mole in the problem, that's your molar mass that you're going to use for molecular formula.
It'll say something like an unknown formula has the mass of blah, blah, blah.
Yeah.
And you have to figure out what that formula is.
Yep. So you find the empirical, then they give you the mass, and you're going to then divide those around the whole nearest whole number, and then multiply the subscripts of the empirical formula by that whole number to get the molecular formula. A lot of mumbo jumbo, but you'll understand as soon as we do this next example problem.
Well, remember when we said, before when we were making formulas that if you have a 2 and a 4 in the bottom, you always need to reduce it? We were getting you to the empirical formula. Now you're dealing with the molecular formula, so if you end up with a 3 and a 6, don't reduce it because that's your molecular formula.
All right. So let's figure this one out.
Okay.
We've got a compound was found to contain 49.98 grams of carbon and 10.47 grams of hydrogen. The molar mass of the compound is 58.12 gram per mole. What's the molecular formula?
Okay.
So here we've got grams, but we also have that gram per mole, so we know we're going to have that added step to do. First thing we need to do is go through the empirical. So we're going to take grams and we're going to divide by the molar mass of each of those items. So 49.98 grams of carbon divided by 12, which is the gram per mole off of our periodic table of carbon. That answer is 4.165.
And that's moles
Yep.
of carbon.
Then we got to do the same thing for hydrogen. So 10.47 grams. And we really enjoy when we get a hydrogen because you get to divide by 1.
Because it's easy.
So then you get 10.47. Now the next step out of the empirical is to divide the smallest mole by everybody. So 4.17, 6 I can read. And then 4.16. So the top one's going to give you a 1. The next one's going to give you 2.5. So another 0.5, sorry.
Yep. So what do we need to do?
Multiply by 2.
By 2. That gives you a 5. This gives you a 2.
So we have carbon 2, H5. This is where empirical would have stopped.
Mhm.
But with the molecular, we have to add up the molar mass of C2H5. So you have 2 carbons, and each carbon's worth 12.
Okay.
That gives us 24 plus 5, because each hydrogen's worth 1, and you have 5 of them. So we get 29 gram per mole is the molar mass of our empirical. We have to compare that to the molar mass that they gave us in the problem.
Mm-hmm.
So what we do is we take the bigger number, which is, it should be, the one in the problem, so 58.12, so the molar mass out of the problem, divided by the molar mass you just added up from in the empirical. So 58.12 divided by 29, and you're going to get a 2.
That's easy.
Now that
Now
2
what?
gets multiplied through the subscripts of your
Okay.
empirical. So instead of C2, you're going to have C4. Instead of H5, you're going to have H10. That is the molecular. There you go. Molecular problems. We'll have a lot more examples, so you'll get the hang of it. Pretty
Right.
easy, straightforward, just a bunch of math to get you to your subscripts. Pretty good?
Pretty good.
All right.